What's up guys, Onmaths here, and today we're looking at histograms. Histograms normally are the grades 7 to 9 end of the exam. So we're expecting this to be a little bit more tricky than maybe previous videos, which is probably a good thing for a lot of you. First up, we're just going to do one question that involves drawing histograms. I think when you've drawn one of them, you kind of get the idea, and then the next couple of questions are going to be interpreting histograms. So, important thing about histograms to know is that the left-hand axis is not frequency. It's tempting to make it frequency, but it's not. It's called frequency density. Okay, and you can write it out as frequency density. Now, frequency density is like a compound unit, like speed is. Speed only exists when you've got a distance and time. That's all speed is a comparison between the two. Or it's a rate of one from the other. And frequency density is kind of the same. It only exists when you've got something on the x-axis, like continuous variable on the x-axis, and frequency. So it's a relationship between those two. And the reason why we create this frequency density thing is because on a histogram it's more useful for the frequency not to be the height, but to be the area of the bars. And the reason for that is if you look at the class intervals here between 0 and 20, there's 20. There's a class width of 20, but here it's 30. So if we did it as the heights, it would be misleading. The big triangle we're going to be using for this question is, just like speed, distance, time triangle, frequency density is frequency over class width. Okay, so if we're looking for the frequency density, which we are in this question, we just do the frequency divided by class width. Now, I've got to just have a bit of a caveat here. Frequency density is proportional to frequency over class width. So you can be fooled in some questions to think, oh, I just I do the frequency divided by class width. But if they give you an example bar, then always just check that that's the case. Sometimes you do frequency divided by class width, and then you need to multiply that by a number to get to the frequency density. So just be careful with that. It's really useful for me to think of it as a triangle still, but just remember that frequency density might be doubled or tripled compared to frequency over class width. Okay, so for this question we're given kind of free rein to do whatever frequency density we want. So I'm just going to add an extra column on this table, and we're going to fill it out with the frequency densities. So, and I'm just going to do frequency divided by class width. So for this first one, I'm going to do 120 divided by 20, which is 6. Next one, 90 divided by 30. And the reason it's 30 is just the gap between these two. So 50 take away 20. That's 3. 120 divided by 30, which is 4. 140 divided by, was it 70? Which is 2. And then 100 divided by 50. I don't know why I've typed that into the calculator, but there we go. Okay, so we've got our frequency densities here. So the highest one's 6, so we can just look here. So 1, 2, 3, 4, 5, and 6 works well. Okay, fits on our axis. Okay, so for the next bit, we need to actually draw the bars, and we're going to do that by well, histogram is like a bar chart in the sense that you get bars, but the widths are going to be different, and you don't leave gaps between the bars. Like, so for the first bar, it's going to be between 0 and 20, because that's what it says in the question here. Okay, so 0 and 20, and the height is going to be 60. So we've got to figure out this x-axis. So I think this is 10 here, so it's going up 2 squares. Yeah, that seems to work. So 0 to 20, isn't it? And it's 6 high. Okay, and the calibration on the thing I'm using is not great, so you can kind of use your imagination maybe. Next one is 20 to 50, and it's a height of 3. Okay, next one is 50 to 80, And so 80 is going to be there, I think, and it's a height of 4. Next one is 80 to 150 with a height of 2. And then the last one is a height of 2 between 150 and 200. And there we go. So you can see that there's no gaps there. I've not drawn it perfectly, like some of these are a little bit out of place. But when you've got a ruler and a pencil on paper, it's a lot easier to do. Okay, next thing we're going to be doing is we're going to estimate the distance. Now there's a few different ways of doing this, but I find the method I'm going to show the easiest. Okay, so with median, we know that to work out the position the median's in, so not the median itself, but the position, we do, let's go back to blue, n plus 1 over 2, n being the amount that we've got. Now if we read the question again, it says we've got 570 students, so we're going to have 570 plus 1 over 2, so we'll get our calculator, so 570 plus 1 divided by 2, and we're looking for the 285th number. Okay, so we're looking basically at the 285th and the 286th. Okay, now we know the frequencies already, so this is going to be 120 there, this is going to be 90, and this is going to be another 120. Okay, so we know the first 120 ones are in the first bar. So what we're going to do is we're going to get 285.5, we're going to take away 120, and that leaves 165.5. So we've still got some left, so we know the median's not in there. Okay, then we're going to take away the 90, which is the second bar, and what we're left with is 75.5. Now, this means the median must be in this bar here. So I'm just going to move that up there, because what I'm going to do is I'm going to try and figure out whereabouts it is. Well, there's 120 in that bar, and we're looking at the 75.5 in that bar. So 75 compared to 120 is roughly halfway, maybe just over halfway. So it's somewhere here. Okay, and we know that we're looking for 75.5. We need the frequency in that little bar that I've just created within that bar to be 75.5. Now, interesting enough, we know the frequency density as well. So we've got the frequency we want, we've got the frequency density we want, and what we can do is work out this class width here just by using that triangle. So, looking at the triangle, we've got the frequency, which is 75.5, that's the frequency we want. We're looking for the class width, okay, and we've got the frequency density. Now the frequency density is 4. So to work out the class width, all we need to do is 75.5 divided by 4, which gives us 18.875. So I'm just going to write that here, 18.875. 875. Okay, remember that's the class width, it's not the distance. That's the amount of distance within that bar. So you can see that that bar starts at 50, so it's another 18.875 after that, so all you need to do is add that to the 50, and that will show you that it's 68.875. So the answer is 68.875. Now, as I said before, this is not the only method of doing this, but for me, this is the best way of doing it. And if you're looking, especially if you're looking at doing A-level, this is basically called interpolation at A-level, where you have to find an exact estimate, which is odd. But you know, when you estimate the mean from a group frequency table, there is only one answer, and it's similar to this. Now, they are more lax on you being precise with this at GCSE. So you probably find in the mark scheme it gives you a nice generous range of values that you can get. but this is an exact estimate, which is a weird, and maybe that's a contradiction or an oxymoron or something. But this is the best way of doing it, and it will help you to understand maybe some of the later questions, and it just gives you a really easy method to be able to get the right answer. Next we move on to our OCR question. Now this is a slightly easier question than the previous one. It's just I wanted to do one that we drew a histogram first, and then this is a lot easier to understand. So don't forget we've got our frequency density, frequency and class width. And for this question, we kind of assume that the frequency density is frequency divided by class width. It's not proportional, that it's the same, because there's no other information. It doesn't give us a bar and a frequency, so we can't really check. So we're asked to just complete one of the bars, but we're told that there's 30 students in total. So all we need to do is find out the frequency we've used up so far with the bars, work out the remaining frequency, work out the frequency density, draw the bar. Simple as that. So this first one, the frequency density is 0.8. The class width is 15. So we just times those together. So we do 0.8 times 15, which is 12. Next one, we've got a frequency density of 0.9. We've got a class width of 10. So that's obviously going to be 9. And then this last one, frequency density 0.2. And the class width is 15, so 0.2 times 15, and we get 3. Okay, so we add those together, and then take it away from 30. So 30 take away 12 plus 9 plus 3. 30 take away 12 plus 9 plus 3 on the calculator. If you've got it, you might as well use it. Leaves us with 6. So our last bar needs to have a frequency of 6. So we need to work out the frequency density. So frequency density is the frequency which we have as 6 divided by class width, which is 10, which would be 0.6. And so our bar will be at 0.6. Bit of a nicer one, and I just wanted to show this because histograms do come up as slightly nicer questions, but the temptation, as always, when you're drawing histograms is to put the frequency on the y-axis, so just try and remember the triangle and you'll be fine. Last up is our AQA question, and the complication with this question is we have no frequency density axis. Well, we have the axis, but we don't have any numbers. And there's a really kind of easy way around this, is you just make the axis the amount of squares, right? So we've got 10 squares and 20 squares and 30 squares. Simple as that, okay? And then we're just really counting squares, and we're just working in proportions of the areas of the bars then. Now, some teachers say to count the big squares. I always find that way more complicated than it needs to be, because if you look at this one, it doesn't work exactly. You've got to work in decimals, and there's just no need to. Just work in small squares, and it's a lot easier. Just the numbers are easier to work with integers rather than decimals. Now, it's important to realise that we're not saying the frequency density is going up in tens or going up in fives or whatever you want to say. We're just using that to be able to answer this question. So what I'm going to do is, again, use the triangle, frequency density, frequency class width. And I'm going to work out how many squares there are in each box. Okay, so I'm just working out how many squares there are. So I say I'm going to use that. I'm going to use that maybe later for a different question, but not for this. So we are only working out the amount of squares in each box. Okay, that's all we're working out. So that frequency density axis I've put is just there to work out the amount of squares. That's it. Okay, so for this first one, it's got a height of 25 little squares. It's got a width of 15. And so I'm going to do 25 times 15, and we've got 375. Okay, for this one, we've got a height of 33 and a width of 5. So 33 times 5, 165. And for this one, we've got a height of 4 squares, a width of 15 squares. I don't know why I'm doing this on my calculator, and that's 60. So now we know the amount of squares in each box, in each bar, I should say. We can work out the total amount of squares. So 375 plus 165 plus 60. So 165, 375 is 600. So 600 small squares. And I think the fact that there's 600 of them is showing that we're talking about the small squares. Maybe I would write small squares because I know the other method is to count the big squares. Okay, so we know there's 600 squares in total, but we also know that there are 480 cars. So what we need to do is work out the amount of squares for each car, or the amount of cars for each square. So you've just got to work out which one you're finding out. So we're going to do the cars per small square, so called cars per square. Okay, and to do that, what we do is the amount of cars, which is 480, divided by 600 squares. So there's 480 cars represented by 600 squares, and so we get our calculator. 480 divided by 600, and we get 0.8. So each little square is worth 0.8 of a car. And obviously we're asked to find the amount of cars in the first bar. So we have a look at the first bar. It's 375 little squares. Each of those little squares is worth 0.8 of a car. So cars in first bar is 375 because that's the amount of squares, times 0.8 because that's the amount of cars that each of those little squares is worth. So we times those together and we get 300. So our answer is 300. There's loads of different ways you could do that. As I said, you could work out the amount of squares per car and do it that way. I think the method I've shown is probably the easiest of the methods to do. You could also you work with algebra and scale it in terms of x up the y-axis, and maybe that's a little bit more precise to understand that it's a proportion, that we're not saying that's what the frequency density is, but it's up to you really. I think the method I've shown here, well, it will definitely get all 4 marks, and I think it's the easiest. Right, and the last question we're going to do today is about the fact that we're looking for the cars greater than 40 miles per hour, and we're looking at estimating. And remember, when you cut a bar in half or quarters or whatever you want to cut it into, it's always an estimate because we don't know the exact values. I mean, for this group, they could all be down here. We don't know, so it's always an estimate. So the first thing I do with this is draw a line up from 40. And it's quite common for them to kind of show an arrow to show where you're going with it. And we're looking for all the frequencies to the right of that line. So I just kind of show the arrow going right. And that's there really for me, just to remind me that's what we're looking for. Let's just make sure this is perfectly on 40. Okay, so this is really no different to the previous questions that we've done. Let's just move this working out a little bit further across. Give us a bit of room. Okay, so with this, all we need to do is find the frequencies, and we can do that the same way and count the squares and then use our conversion that we've just worked out in question A. So we know that it's 4 up, so 4 squares going up, and we've cut this so that this is now 10 going across. So there's 40 squares, and I'd probably write that in my working out down here. So 4 times 10 equals 40. And then we know to convert it, we just times it by 0.8 because each each square is worth 0.8 cars. So we just do 40 times 0.8. Do it on a calculator. 40 times 0.8, and that's 32. So the answer is 32. Now it's misleading sometimes when they leave loads of space and it's just a couple of lines of working out. But the hint here really is it's only 2 marks. So you're only looking really at doing 2 things. Again, this question has loads of different ways of doing it, but I think this is by far the simplest because we've already done the hard work and worked out the conversion. So we might as well just find the amount of small squares and then use the conversion to find the frequency. Well, I hope you found that video useful. If you did, please click like. If you want to see more from us, release videos every single weekday at 9 o'clock in the morning. Just click subscribe and the bell icon to make sure you're up to date with everything we release. If you want to see even more from us, we have a really fantastic website, onmaths.com, just packed full of really great resources to help you with your maths. Just click the link that magically appears above this video now. Otherwise, thank you very much, and I'll see you tomorrow.